Hello all, welcome to the Techogenius Academy. So this is the second part of Linux device driver programming. In our last video, what we discussed? We discussed about the introduction to the Linux kernel. We discussed loadable kernel module, how we will insert the module, how we can remove the module. We have discussed some character device driver operations where we can access the major number, minor number, how we can write the device files so that we can communicate with our driver, how we can communicate with user space and kernel space by using copy to user and copy from user. Few file operation structures we have discussed in our last video. So now we'll demonstrate each and everything in our video. So let's get started. So what I will do, I will just go to the super user. I'm just writing my password. Right. So now I'll create one directory here. LDD. I'm entering into that directory. Now I will create a file. Okay. So now, first of all, we'll include all the header files because later on, if we don't have include any header file, so that will be difficult for us to recognize. Hash include linux slash kernel dot h, hash include linux slash init dot h. Okay, slash include, these are for kernel module programming. That in our earlier video we have discussed module underscore init, module underscore exit, hash include linux slash kdev underscore t dot h. This is for our device file. Linux slash fs dot h, file structure, hash include linux slash cdef dot h for our cdef structure, hash include linux slash device dot h for kmalloc, hash include linux slash slap dot h. For communicating between user space and kernel space, we have used the function calls like copy to user and copy from user. For that, we need to include ua access dot h. So first of all, what we will do, we will write our init function, init module function, static int underscore underscore init. I discussed in the last video what is the use of underscore underscore init. If you don't know, please go watch our previous video, because in this tutorial, in this code, you can't understand what is happening. Okay, so this is for init module. I've just declared the prototype kind of stuff. Static void underscore underscore exit chr driver, my exit function. Okay, so now what we will do, we will write the body of this init and exit function. Static int underscore underscore init chr drp dr driver underscore init void. Right, so now first of all we have to allocate the major number, the first thing which we have discussed. So I'm just making the comment here just to have the better understanding. One second. Okay, alloc chr, we can write chr dev alloc character device region, address of some device 0 1 here, my underscore dev. So we will see in cat proc devices that your file is created, your major number is created. Print k kern underscore info. This is for kernel information, like whatever we are using in printf, it's slightly different in kernel space. We are using print case here. Cannot allocate the major number. Right, so we'll return from here, like -1 will return. Okay, so as you have seen, I have just written a device as a first argument, so we'll just initialize this first. Dev underscore t dev equals to 0. So one second, I'll just go to that slide. Yeah, so just see, allocating major and minor numbers. So we did it in two ways, statically and dynamically. So now I'm creating this as a dynamically. Okay, so device is your device number, unsigned in first minor number, after that count, after the name of that device, which will present in cat slash proc devices. Okay, so later on what we will do, we will just print our major number and minor number. major number and minor number. This method I have shown in my PPT. Just check it out. I showed you this major and in arguments we have to pass that device, and in minor same thing. Now we will create a CDEV structure. CDEV structure, as we have mentioned, CDEV underscore init. Here we need to pass our CDEV structure. So what we can write, my underscore CDEV, that will be right. And we need to pass our file operations structure, right? So we just need to initialize our structure, static struct CDEV. We can write as a my underscore CDEV, right? So what is this file operation structure? So CDEV, as I explained you, if you want to open, read, write, close the file, then you need to write a file operation structure in kernel driver. To do that operation, we can just write static struct file underscore operations first thing we need to write dot owner this underscore module. This will be the owner. After that, dot read my underscore read dot write my underscore write. Open my underscore open. I'm really sorry, I really hate making long videos, but in this tutorial I need to explain you each and everything step by step, so it'll take a long time. That is just for you guys. My underscore release. Okay, so that's it. Yeah, so in this way we can create our file operation structure. So we have just initialized the CDEV structure. Now we have to add that character device to our system also. So to do that, we'll add our CDEV underscore add function. So adding character device to the system. If CDEV add address of my underscore cdef, comma our device, comma 1 0. We'll just print the logs like error that it's not created if it's less than 0. Cannot add the device to the system. So now, if we are unable to allocate this class, so what we need to do? So we'll just write the go to thing. So if you know about the C stuff, you can easily recognize this. I'll just write it here down you later on, because this we will do use also when we are creating the struct class. So in this, what we will write, we will just unregister our character device region, which we have allocated by using alloc dev region, right? And from here we will return as -1. Okay, great. So now what we will do, we'll create our class. If what we can write, our device like dev underscore class equals to class underscore create our owner, this underscore module, and the name of that class. So we can write my underscore class. That will be easy to see. Is equals to null, then we'll just write that we are unable to allocate our struct class, right? Cannot create the struct class. Right? So now to do this, we'll just unregister the our character device region, right? So now we have created our struct class. Now we need to create our device. Creating device. So I've clearly mentioned that whatever the return type of struct class, we need to pass as a first argument to the device create. Device device underscore create dev underscore class comma, we'll make it as null, our device, this also, and we can write as a my underscore device. Is equals to null print k, just to tell that information that we are unable to allocate the device, cannot create the device. So here we will put the go to r underscore devices, so we'll destroy the device. Okay, r underscore device class destroy, because we have created the class but device is not created, so we need to remove this dev underscore class, right? Great. So here we can just print like for better understanding, like our device driver is inserted properly. Okay, so this is our init function, right? So now what we will do, we will write our exit function, void underscore underscore exit chr driver exit void. Okay, so what we'll do, now we need to destroy our device first. To do that, device underscore destroy, this call I have mentioned in my PPT. We need to destroy the class also. We need to delete our cdev structure, remember. My underscore cdef, and after that we'll unregister our character device region. So if all these operations is successfully done, then we can write it here that device driver is removed successfully. Device driver is removed successfully. Right? So if you remember, we discussed to call this initialization function and exit function, we need to write macros module underscore init and module underscore exit. Right? So now here we will just write some macros. Module underscore license means you are using the free license. Okay. Module underscore author. There are so many macros available. Techo Genius. Yes. Academy. More Techo Genius 7519 @gmail.com. Right? For description, we can write the corrector device driver. Great. Okay, so we have written the init function, exit function, our macros, and now whatever the file operation structure we have just declared here, we need to define the bodies for that. To do that, first we'll write the prototype. First we'll write the open call. We'll pass the first argument as the inode structure. Your file structure. Theme for release. To read from that, s size underscore t my underscore read struct file will just declare here as a file p. Okay, character underscore user star buff. This will be a buffer. Size underscore t length. This will be our offset. Great. So similarly, we need to write it for our write function. Constant character buffer, size underscore TLEN, and our offset. Great. So now we will define each and every body of this. So, I think I've missed one thing. Okay, so the dev underscore class we have not created. Like, we need to declare it here as static struct class dev underscore class, right? Great. So now first we'll write our open function struct inode star inode struct file star file. So we'll create a physical memory by using kmalloc. Creating physical memory. Kernel buffer equals to kmalloc your memory size. So memory size we'll write it as a macro gfp underscore kernel. So this will be the flag equals to 0. Print k kern info cannot allocate the memory to the kernel. And will return -1 from this. If it's successful, we'll just write device file found. Sorry. And will return 0 from this. Right. So what we will do, we will just create the macro for memory size hash define mem underscore size 1024 will be fine. Okay, so for kernel buffer, what we will do, we will just write unsigned int 8 underscore t star kernel buffer, right? So now we will write our release function. So we will just free the memory what we have created by using kmalloc, right? Great. So now we will write our read function. For read function, we need to use the copy to user call. Our buffer, our kernel buffer, and the mem size, which will be your memory size. So whenever we are writing or we are calling the read function from the user space, it will come here. So I can show you the log over there. I will just write the log in user space application so we can easily understand like how the flow is. Okay. So now we are returning the memory size from here. So this is I'm writing for my write function. My buffer, my length, and the offset. So in this we will write copy from user. We need to pass our kernel buffer first, after that buffer, after that the length. Data is written. Successfully. And we'll return the length from here. So why I'm returning the memory size, why I'm returning the length, so you just need to figure it out and mention in the comments, so I'll just reply to that. So just see this thing, what we have written. We have written our init function, our exit function, our open, release, read, write, our file operation structures. So basically we have written most of the things. Yep. So now what we will do to run this file, we need to write the make file. So object hyphen m, whatever our file name is, I'll just okay, chr underscore drv underscore ex1. Okay, chr and equals to chr underscore drv underscore ex1 dot o, because this will be your object file. Kdir kernel directory slash lib slash modules slash dollar. Here I'm using the shell command because this will go to the kernel version Linux slash build pwd, our present working directory, dollar, again I'm using the shell command pwd, so it will search in the present working directory also. Default dollar make hyphen change directory dollar our kernel directory subdirectories equals to dollar pwd modules. Modules. Okay, for install same thing, but here we will write module underscore install. For cleanup, we will write here as clean. Okay, so this is our make file. So we'll just try to compile this. Okay, some errors are coming. Okay. 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 Here I've just written it in a wrong way. Okay, I have used here printf. Sorry. Okay, so there are so many errors. So I'll just fix this up and I'll come back. Okay, so I have just removed all the errors. like it's just like a print case. I have just mentioned that printf over there. Okay, so now we'll use the make command. Okay, so now our driver is, we have run this and we just got the .ko file. Okay, so now what we will do, this is our kernel driver. So now what we will do, we'll go and write the user space application, because we need to test it from our user space, right? So I'll just create the directory test app. Okay, vi test chr drv.c. Okay, so we will start by writing the header files. I'll just make it big. Okay, stdio.h hash include stdlib.h hash include string.h. So why? Because this because these are the standard header files we are using in like reading and writing and all these operations if we want to do. So this we are using. So we will later on start like we will later on write all the header files if we include, like if we want. Int main, first will be your file descriptor. Here we will write your options. So printf, it's like, okay, welcome to the character demo of character device driver. What we will do, we will just open the file. So now what is the path we need to mention here? It's like every character device is present in our device file. And what is that path? Slash tab, that device file which we have written in while creating the device. So I have written my underscore device. This permissions we need to mention here: read write permissions. Okay, so if fd is less than 0, we can't open the device file. We are unable to open the device file. We'll just return 0 from this. After that, we will just rotate the loop, because driver is live and we need to use this read write operations. So we can just mention the full description, full options into that screen. Please enter your options. So this will be on your display. printf first will be your write, then it will come your read, okay, then it will come your exit. Right. Now we will scan the option. Printf your options are we'll just write the operation here, like what operation we have chosen. Now we'll write the switch case here. Option for first case we'll just write the print here just to make the better understanding on the screen. Enter the string to write into the driver. We'll scanf percentage bar slash t slash n closing the bracket s. So this is the proper specifier when we are writing the buffer. So here okay, so we'll just write write underscore buffer, so this will declare data written write. Now this we will write fd your write buffer string length of write underscore your buffer plus 1. Sorry, printf done. We will break this. Okay, so second case will be your read. Before that we will just write we'll just declare the read and write buffer over here. Int 8 underscore t write buffer, we can just mention the size 1024 will be fine. Int 8 underscore t read buffer 1024 Okay, great. So now we will write the read function. Data is reading. We'll use the read call fd, comma, read perform 1024 printf. We'll just write it as like it's done. So we can just we can write the data also here, just to check like what we have written, its display here. Case 3 will just exit. So for to exit that, we'll just close our fd. We'll write exit of 1 and we'll break. Default functions we can write like if apart from 1, 2 and 3, if we have written any like wrong option, so it will just show you the option that enter the valid option. We'll close the file descriptor here, because if it will not go to the default function, right? So we will just try to compile this. Okay, some errors are coming. Oh, sorry, like I've just missed this something. Okay. Okay, just give me a second. Okay, so what happened here? Like I just forgot to mention some of the header files, so that's why it's giving some error, because I've written correctly only. So I just thought like why it is giving me error. Yeah. So now our driver. Okay, where is our driver? This is our driver. So we will just insert our driver, character driver Q. Okay, so ls mode head -5. So chr ax1, it's present over there. Proc devices, so we can see the our device file here. Okay, 236, just check my underscore dev. Okay, and we can just cr logs also. Okay, so the 236 device driver insert done properly. Okay, this is our things like we have written in our vector driver. So now we have successfully inserted the driver. So now we will check this application by running sudo slash test character driver. Okay. Okay, welcome to the demo of character device driver, and please enter your option 1. Enter the string to write into the driver. Okay, so Techo Genius. Data is written, done. So now we need to read the file. Okay, data is reading, done. Data is Techo Genius. Great, awesome. So you can easily understand this. Okay, I'll just use 3 also to exit it. Okay, so we will go to the driver part. So you can just see device file open, device is written successfully, data read done, device file closed. So in this way you can just write your character driver and you can communicate with the user space. So thank you so much. Please don't forget to like,